the first one, we wrote these, we changed, instead of the radical, we wrote it as a power. Okay, the whole thing is under a cube root. What kind of power is a cube root? 1/3. Underneath that cube root, we have an x times a square root of x. What kind of power is a square root? Okay, if you are multiplying these, what do you do with their exponents? Add them. The x is written each time, so we add them. So this is like an x to the first. So 1 plus 1/2 is 3/2. And this whole thing is to the 1/3. Then what do you do when you have a power to a power? Multiply. So 3/2 times 1/3 is 1/2. So those were the ones that you guys had a little more trouble with on the Math Excel. There'll probably be one like that on your quiz tomorrow. So you have to write it with those fraction exponents and then simplify as much as possible. Let's look at number 2. If you have the 4th root of y, how do we write that? Times the 5th root of y would be y to the... Then what do you do with those exponents? Add them. So 1/4 plus 1/5. 9/20. Okay, number 3. Let's start on the inside. If you have the 4th root of z cubed, you would write that as z to what power? 3/4. The denominator is the number outside your radical. To the -6. If you have a power to a power, what do you do with those? Multiply. So 3/4 times -6 gives us -9/2. And the last thing I would want you to do, if you have a negative exponent, what does that do? Moves it to the bottom. So your final answer is 1/z to the 9/2 power. Questions on those examples? The second type of problem we did in this section was giving the domain. And you really just had to pay attention to whether it was an even or an odd root. Number 4 is a 6th root. That's an even root. If you have an even root, what do we know?
Under the radical.
Right. Just like if you're doing a square root, we can't do the square roots of a negative without getting imaginary numbers. So if this number is even, you take the thing under the radical, greater than or equal to 0. And that's all I care about. I don't care about any numbers out here or anything added on the end. So if I solve this, if I add my x over, I get 5 is greater than or equal to x. So that means x is less than 5, so it would be -infinity to 5 equal to means a bracket. So tell me you can put in everything smaller than 5. Okay, number 5. This one is a 5th root. So even roots, we can't have negatives. Can you do like the cube root of -8? Yes. So if this number is odd, what is your domain automatically? Okay.
You said if that number is odd.
So if it's like a cube root, fifth root, seventh root. The last type of question in section 4. If I asked you to use a transformation, tell me the transformations that would be used to graph this thing. Except you have that 25. What did we use? Yeah. The easier way to see how it's stretched is we actually factored something out. 25 and 50, those are both divisible by 25, right? If you pulled out that 25, so if I want to bring that 25 out of my square root, what is the square root of 25? So this is 5 radical x minus 2 plus 4. So what's the 5 do? Yeah, vertical stretch by 5. What's the minus 2 do? And the plus 4. So we factored out anything that we could, and then used this one to give the final transformations. Okay, so tomorrow is a quiz over sections 4 and 5. If you can do this stuff, you're going to be good on the section 4 stuff. Okay, so this is like the front page of the quiz, questions like these. The back page of the quiz is the section 5. So you had the Math Excel yesterday that you were finishing up. That one's due by 3 o'clock today, I believe I have it set at. So if you still have a couple questions on it, make sure you get that done. Then I also posted a handout on Classroom to review the section 5 problems. So you have the rest of the hour to work on that handout. It will be due tomorrow. Work on the Math Excel if you didn't get that done. Ask questions when you need to. I don't mind if you help one another, but please make sure you ask me if you need anything.